Bueno, arrancamos entonces.
So let's start. My name is Damián, and I'm part of the research and development team of GeneXus. You probably heard my colleague Eugenio Garcia talking about myths and realities of artificial intelligence, and Luis Murillo, who spoke about integrating AI in our projects. Now I'm going to focus in what we are doing at GeneXus in general with regard to AI. Why in my presentation I say AI for everyone? Let's say what Gina. Let's look at what Gina says. It was said on March 2018, and she says the story of enterprise machine learning. It took me 3 weeks to develop the model. It's been 11 months, and it's still not deployed. This alludes to a comment made by Dinesh Nirman, the vice president of IT development in IBM. The video of the conference is in YouTube. You can watch it, it's very good. And this is the case of mostly everyone with regard to artificial intelligence. When we try to develop the model, it doesn't take so long, but after doing several things, training, etc., we realize that the process can take much longer. The first thing that attracts our attention is how she managed to develop the model in 3 weeks. In general lines, AI tries to model a function on the basis of examples, understood as entry data, which would be the X, and outgoing data, which would be the Y. If we have both things, we can model the function. And this is applied maths. Artificial intelligence is, in the end, applied math, and we need knowledge about statistics since we are working with real data, knowledge about linear algebra in order to have computable algorithms. We need to know calculus in order to optimize the algorithms, and also know about probabilities since we are looking for the best approximations to the solutions we want to find. And this is necessary to design the model, and it would seem a utopia to be able to do it in just 3 weeks. Besides, when we design an AI model from scratch, the first step is data acquisition. Large volumes of data, and what do we want to learn about the data? This is something that we overlook very often because we say we have a great deal of data and I want to apply here AI or machine learning, and it's not so easy. If we know what we want to obtain or do with the data, then that's the way to go. Otherwise, it's pointless. The second step, after we have the data and we know why we want to train, we have to do the feature selection on the basis of this data so as to infer what we are trying to learn. Then there is a stage of training and tuning of the model, and this can take quite a long time too. Depending on the resources we have, it could take days or even weeks, and it's quite a costly stage. Then there is a stage of testing and evaluation. We will be assessing how the model was built and whether we agree or not with the predictions it's making. If we agree, then and only then we can go to the deployment of the solution. What happens then? What happens is that usually during the testing and evaluation stage, if we are not happy, we have to go back and execute the whole site again, and maybe we won't be able to do the deploy in a reasonable lapse of time. Big companies saw here a big business opportunity. They tried to group these three stages and find a compact solution without having to worry about implementation details. And Amazon, Google, Microsoft, IBM, SAP, as well as Chinese enterprises such as Baidu, Tencent, and Alibaba come up then trying to simplify the process of the design of the machine learning or automatic learning design. And they try to simplify this loop in which we are trying to find compact solutions. What kind of solutions? Machine learning is divided into three levels. Firstly, the processing of natural language, which is quite good nowadays, but there's still much to do. Then computer vision, everything related that is related to the processing of images and videos, and then predictive models. Based on some data, we can predict certain values, like the example Luis Murillo presented, to predict the price of a house based on its features. And then we have the generative models. The machine can generate things never seen before, like a photo or a song that no one composed. But this is something that is just now coming to light. Nowadays, the big companies I just mentioned have their strength in language processing and computer vision. They are doing something also with regard to predictive models, but it's still a work in process. If we analyze these two big paradigms in the ecosystems, we see the unstructured data processing. For example, the audio, which is a sequence of bytes that represent sounds. We would like to be able to analyze it and process it. Same thing for the images. We have a sequence of pixels and we can extract information from them. Processing of natural language. Language in itself is ambiguous and has many particularities, and from there we can extract information. And then video processing, which merges the audio and images thoughts plus a temporal value, the time in itself seen as a sequence of frames. So what's inside of this? In audio processing, we can do the recognition of speakers, the transcription of audio texts, and vice versa from audio to text. In the processing of images ecosystem, we can have face recognition, recognition of objects, classification of images. In processing of natural language, we have the systems of automatic translation, finding inadequate content or analyzing opinions, see whether it's positive or negative, and some other features of language from a linguistic point of view, syntaxes of language or similar things, keywords, etc. And with regard to videos, it would take advantage of the first two paradigms, analyzing the temporal variable, and we can find statistics, for example, for how long a person was on a video or was speaking. And now I'm going to explain the built-in model of GeneXus AI, which you can find in GeneXus scene. It's easy to install and you have it in your knowledge base. What are we looking for with GeneXus AI? As I said, we have these models that are complicated to design and need this cycle of training, testing, etc. And as I said, the large competitors come up with the cloud. With GeneXus, We don't want to learn a solution in particular, that of IBM or Microsoft, for example. We want to have a unified API for all of these suppliers so that you can integrate easily in GeneXus. That's the objective of GeneXus AI. In a release we did yesterday of GeneXus 16, we have already incorporated these three, Microsoft, IBM, and SAP, and we will be working on the others in the next upgrades. We also intend to incorporate offline solutions which would be based in Core ML, for example, and they would run directly in the server or your mobile devices without needing to communicate with an external supplier. But at the level of GeneXus, it behave as just one more supplier. It would be just a configuration. And since GeneXus AI is inside GeneXus ecosystems, we will be able to benefit from the generators that we have and that you see on the screen without adding additional complexity. How is GeneXus AI structured? We have an audio module that allows us to process this kind of data.
Ahí. Vamos de nuevo. Ahí. Bueno, ahora sí continuamos. Le comentaba.
As I was saying, we have the audio module.
No quiere con esa diapositiva. No quieren que les muestre GeneXus ahí. Ahí volvió. Por las dudas me voy a mover de acá. ¿Se con esa slide? Ajá. Qué divertido. A ver. No, son transiciones nomás. ¿Tengo? Ahí va. Tengo acá un video. Ahí va. Vamos a mostrar el chiste que le quería mostrar al final, pero ahora les hago un repasito nomás. Tenemos el modo.
Well, this is a joke I wanted to show you at the end. Okay, so we have the audio and video, we have the speech to text, and we can do it the other way around. Then we have on that side the image module, and we have a method to classify images. The detect faces feature that can detect the faces on an image, and for the time being what we are using are the default model of which one of the suppliers I told you about. Now they are evolving and we will be able to put in our own data and not only identify faces but also say according to their features, but also say this is Damián, this is Fede, and this is something that we will be including in the coming upgrades. We can also detect objects, detect scenes. If I have a photo in New York, hopefully someone takes my picture and it can detect that it is taken in New York. And then OCR, optical character recognition. Then the text module with the detect language, extract entities, key phrases, sentiment analysis and translation, and finally another module to detect videos. Well, I hope this slide will stay on the screen. We have another additional module, configuration, and there we will have a provider. We will configure the service we are using, the type of provider, and some properties and the access credentials to these providers. Then we will have a domain of providers in GeneXus AI. And with regard to the code, the only thing we do is to configure the provider. In this case, we say that we want to use the speech of IBM. We configure it. Then we set the properties, in this case the credentials, to have access to the service of detect speech, and we invoke the function. So it's a GeneXus procedure like any other. We have the text, the type, the voice type, locate for the type of language in the provider we just configured, as well as messages in order to handle possible errors, for example that the credentials have expired or something else. And then we can reproduce the audio in our devices. What's the advantage? If one day I want to change because I'm not happy with IBM service, the only thing to do is to erase these two lines and configure that I want to use Microsoft as my provider, and I can invoke a function in exactly the same manner without doing anything else. Then we have minimalistic solutions which we can intertwine to get more complex things. For example, here we have speech to text, and we can translate the text. We can go from one text to another, and to the translated text we apply the text speech. So finally we have a speech translator, and this is something we can do in quite a simple manner. With Marcos Crispina, we will be in the lab this afternoon at 3. We can register at the Secretariat if you wish to attend, and we will be playing a little bit of this. And then a proof of concept. This is a concrete example that we will publish in GeneXus Wiki. It's just a mobile application that has 3 tabs. The first one, which uses the audio module, and there we will see a button that launches a text-to-speech with the necessary parameters and the things I just told you about. And let's see how it works. We have the edit and we write something simple. Good morning, everyone, and welcome. to this GeneXus 28 event. We press the button and we wait for the audio. Good, isn't it? And we can do something a little bit crazy. For example, here we can format in the XML style. For example, to give it intonation. Here we use the prosody and tell it to say it in a low voice. So you probably heard the difference, right? And I have another example, but in a louder voice. The second button you see on the screen does the opposite. On the basis of the audio, it gives us a text. Let's see how it works.
1, 2, 3. Ahí procesa. Un ejemplo muy...
Now it's processing. Testing 1, 2, 3. Hello, testing 1, 2, 3. I have one more example. My name is Damián, and I thank you all for attending this speech. Now, the difficulty is identifying my name. Let's see if it can. Yes, it's really good. So, the second tab has the image module. We are going to use two functionalities. The first one for face detection on the basis of an image. What I do is to take a photo. That's me during the weekend preparing a demo. I'm going to use this photo. It's processing now. And we can draw a rectangle with the face it has detected. It's saying that I'm male, 26 years old. And this is a photo we took a few days ago with Jessica. And what I want to show you with this example is that it's detecting my face. This time it said I'm 23. And look at the precision. It identified someone else at the back, which is supposed to be 32. So these models are quite accurate. Now, the following button is for the OCR function, extracting a text from the image. We repeat the process with the camera. That's me again, and that's my badge for the event. Once it ends processing, it should show us the rectangle where it identified things. And it was not as accurate as other times, and this is one of the things we have to take into account when we choose one or other provider. Finally, language processing. We have again two buttons. The first one to analyze feelings. No, it does the translation. I'm kidding. So if I write down something as welcome to GX28 and we translate it into Japanese, and maybe someone coming from Japan can tell me whether this is a good translation for welcome to GX28. And then we're going to translate this into English, and we see that it is accurate. And then we are going to translate from English into Spanish. And again, the translation was correct. Now, it can identify the language in which I am writing, but I'm cheating a bit because I used the detect language method before calling the translator. So first, I asked the system to detect the language, and then I gave it the target language. And finally, this last button that analyzes feelings. We are going to write down an opinion. In this case, positive. Damián, you're running out of time. You should finish. And the result was negative. As you see, there is a score between 0 and 1. Closer to 0 is negative, closer to 1 is positive. And now here it says, I hope you have enjoyed this demo. And the phrase is positive. And GeneXus is saying goodbye for me.